Welcome to today's class on functional analysis. Today we will discuss bounded inverse theorem. 11.1 Bounded inverse theorem. Bounded inverse theorem says that let X and Y be Banach spaces let F element of BL of XY be bijective then F inverse belongs to BL of XY. So this is the bounded inverse theorem. So proof, let F element of BL of XY be bijective. Let F inverse from Y to X be defined by F inverse of F of X equal to X for all X in X. Then for X1, X2 in X, and K1, K2 in K, F inverse of K1 F of X1 plus K2 F of X2 is equal to F inverse of F of K1 X1 plus K2 X2, which is possible since F is linear. But by the definition, F inverse of F of K1 X1 plus K2 X2 is K1 X1 plus K2 X2. This is equal to K1 into, here X1 is actually F inverse of F of X1 plus K2 into, and X2 is F inverse of F of X2. Therefore, F inverse is linear. Since F from X to Y is continuous, it is closed. Now, F is a closed linear map implies that F inverse from Y to X is closed. Is a closed linear map. 4. We can prove this. 4. Let Yn converges to Y and F inverse of Yn converges to X in X. Let Xn equal to F inverse of Yn we have xn converges to x, since f inverse of yn converges to x. That is, xn converges to x in x and f of xn equal to yn, which converges to y in y. Since f is closed, xn converges to x and f of xn converges to y implies that y equal to f of x, which implies x equal to f inverse of y. Therefore, f inverse is closed. Okay, that is x and y are Banach spaces and f inverse from y to x is a closed linear map. Okay, therefore, by closed graph theorem, f inverse is continuous. Therefore, by closed graph theorem, f inverse is continuous. Therefore, f inverse is a bounded linear map. That is f inverse element of BL of xy. This proves the bounded inverse theorem. Now, remark. The completeness assumption in the bounded inverse theorem cannot be dropped. The completeness assumption in the bounded inverse theorem cannot be dropped. For example, consider x equal to c naught naught with one norm and y equal to c naught naught with infinite norm. Now define f from x to y by f of x equal to x for all x in x. Clearly, f is a linear map. And bijective. For x element of c naught naught, we have 1 norm of x equal to summation over j in n mod x of j, and infinite norm of x equal to supremum over j in n mod x of j. Therefore, clearly infinite norm of x is less than or equal to 1 norm of x for all x element of C0 naught. This means that infinite norm of f of x equal to infinite norm of x, which is less than or equal to 1 norm of x for all x in x. Therefore, f is continuous. But f inverse is not continuous. Since for xn equal to 1 1 etc. 1 0 0 etc., where 1 occurs in the first 10 positions. We have infinite norm of xn equal to 1 by the definition, and also norm f inverse of xn equal to norm xn, and this is equal to mod 1 plus mod 1 plus etc. plus mod 1 plus then 0 plus 0 plus etc., and which is actually n. That is adding 1 n times we get n. This is for n equal to 1 to etc. That is norm f inverse of xn equal to n. Therefore, f inverse is not continuous.